everyone. Thanks for joining us for today's webinar. My name is Shule Tatar. I am the marketing manager at NOPSEC. NOPSEC is the leading provider of vulnerability risk management and penetration testing. Today, we are presenting SMB Tools with Shawn Evans, presented by Shawn Evans. Just a little housekeeping before we get started. If you have any question during the presentation, please type them into the question box in your WebEx control panel. I will bring them up end of the presentation, and this webinar will be recorded. Now, without further ado, we will turn the time over to Shawn. So Shawn, stage is yours.
Thank you very much for the introduction, Shule. And as she mentioned, we're going to be discussing SMB Tools today in this webinar, and more specifically SMBMap. And I want to give you insight into how I use it on every single engagement as the creator. So it'll be a pretty good background on it. So I've been in the InfoSec and offensive security community for about 14 years now. I'm the head of security research here at NOPSEC. And over the 14 years, I've had extensive experience in pen testing, adversarial simulations. I had a background in software development, kind of before I went to the dark side and started attacking software versus creating it. And just, general, a lot of consulting and industry experience. So what I want to cover today is just how to think like an attacker. How does a hacker evaluate your SMB environment? And to do that, we want to understand what SMB is and why attackers so often target it within your internal network environment. And before we dive into SMBMap, which I'm intimately familiar with, I want to also cover the gaps that SMBMap does not fill and what other tools I use when evaluating SMB within a corporate environment. And this is really, we're talking about a protocol that's only deployed in internal environments. And then we want to arrive at why SMBMap exists. What gap does it fill? And finally, we'll learn how to use it the way I use it and give you some live demos, because those are always a little bit more interesting than staring at a slide deck. So just to give you some idea of what NOPSEC is, we're a SaaS solutions company based in Brooklyn, New York. And what we do is focus on vulnerability reprioritization. And what we do is use machine learning to learn as much as we can about vulnerabilities that are known in the world and reprioritize and reassign their risk based on different factors. And if you want to learn more, you can contact our sales team. They are the experts in that realm. Thankfully, I just get to do the technical talks. So what is SMB protocol? It stands for Server Message Block. And what it really is a TCP-based communications protocol specifically designed for sharing files and printers with other nodes on your network. It works over TCP, it used to work with IPX and a lot of legacy protocols, but now it's primarily TCP. Initially invented around 1985 or so by engineers at IBM, but it really didn't see any consumer traction until Microsoft kind of adopted it and made some changes to the SMB protocol themselves in the very early 90s. So you're talking Windows 3.1 and the NT server era. So these are precursors to Windows 95. It has a client server architecture, so it's a pretty standard protocol in that respect. It, has a client that speaks SMB to a server that is also hosting SMB, and it sends a request and says, hey, I want to access this file. Can you help me do that? And the SMB server says, yeah, sure, here's the file. So it's a lot like an FTP server in some respects, but it offers a lot more functionality that is deeper than FTP through what's called an IPC share, or the inter-process communication share. And what this is effectively a way for the protocol itself to do things beyond just what an FTP server can. So it uses these inter-process communications to do things like remote administration, authentication, and on the back end, what it's really doing is using name pipes, which is the prescribed methods within Windows environments to have processes communicate and exchange information with each other. It's kind of similar to a socket or even an SMB share, but it's really just for localized process-to-process communication. You can use name pipes over a network, but in this context, it's purely local. SMB uses NT domain authentication to validate access. So in the early days in SMB 1.0, it only supported LAN Manager and NTLM. LAN Manager being a precursor to NTLM, both of which are pretty rudimentary means through which Windows had initially encrypted credentials. They're both very easy to crack, LM more so than NTLM, and Active Directory authentication is the third kind of protocol. And I think that's what most people are familiar with. And really, when we talk about Active Directory, we're talking about Kerberos authentication. So those are the three primary means through which you can authenticate to SMB. Initially, in its inception, version 1.0, it used NetBIOS almost exclusively to do name resolution on the back end. And that was fine, it was functional, but NetBIOS is a broadcast name resolution protocol. And anytime you have a broadcast protocol in operation on a network, especially in NAS, the more of these nodes that pop up, the more congested a network gets. So that's really when you saw, when you're talking about the early days of SMB and the performance hit, if you had a huge SMB environment, it was really talking about the fact that your network would be congested with just thousands of NetBIOS name resolution requests because it didn't support DNS until 2.0. And now, obviously it supports that in 3.0. But the fact that it has NetBIOS as the backwards compatible to this day name resolution. So, DNS fails in Windows environments, it kind of goes DNS, NetBIOS, LLMNR, and then it says this host doesn't exist. So there's some redundancy that's baked into it, and that's all to be backwards compatible with SMB 1.0. So we'll get to why that's important a little bit later into the presentation. So as far as why attackers want to target SMB within your organization, typically from what I've seen over the years of doing these kinds of assessments on internal networks, is that the bigger the organization, the bigger the attack surface. And the bigger the attack surface, the less visibility an organization has into these threats. Because it's relatively easy for a large organization to have a vulnerability management program in place. There's tools that are designed to scan thousands upon thousands of assets for known vulnerabilities and areas of risk on a day in, day out basis. But if you happen to have an SMB share, this is going to be way, 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 way down on the list. It might even be listed as an informational vulnerability versus something that's actionable that you can apply a patch to and resolve. So because of this, there's a blind spot in most large organizations. The second reason, SMB shares are incredibly easy to create. And because of this, they're also very difficult to lock down and kind of, keep track of where these things are started. And oftentimes you find that, a user might be granted administrative rights within an environment so they can install their own software. But the second that you delegate those administrative rights to a user, even if it is for something benign like installing, software that they intend to use for their job, they can also make configuration changes, so you have somebody from the accounting department that says, hey, I just need access to this weekly spreadsheet. Can you users like, hey, I can just set up the file sharing thing. It'll be really easy. And before you know it, you didn't assign the permissions correctly, and anybody on the network can access this share drive versus the one resource you wanted to. And sometimes the damage could be much more than that. SMB facilitates local and domain attacks. So when we're talking about a local context, you're talking about submitting credentials, and it'll compare your credentials to a local SAM hive on whatever the SMB server is. And this is kind of an attack scenario where if I'm attacking local SMB authentication, I want to know where administrative passwords are reused within the environment, right? So these are going to be situations where it's like, okay, the admin has a super secure password, but that super secure password is on like 400 hosts in the environment. So in those scenarios, you can use SMB to target those hosts. On domain attacks, it's the exact opposite. Domain attacks, you're typically routing your traffic through one SMB server, and you're going to just roll through tons and tons of usernames to find out which user might have password 1 or winter 2020 or something like that. So SMB is very well suited for password spraying attacks of all kind, be it local to try to identify instances of pass the hash, or domain-based for password spraying to identify weak passwords within a domain. There's also null sessions. This is a tremendous way for, you get a lot of bang for your buck as far as attack complexity for the information that you can get out of it. So one of the situations that we see very often is a null session on a domain control, which then enables us to dump the usernames, the groups, the group membership, sometimes even the password policy. And finally, the reason that we target SMB is because it contains anything and everything that your organization has ever created in a digital capacity. So it's, your digital footprint is literally out there in your SMB shares somewhere. More often than not, all it takes is a very, very low privileged basic domain user to get access to information that I should have no business accessing, from bank transactions, from your Swift core banking, backend banking systems, not like consumer bank transaction receipts, payroll information. So you're talking about salaries and social security numbers, web application root directories, just spreadsheets chock full of third-party and first-party passwords. There has been email backups. So, the thing that I can just download and import immediately into my Outlook, and I'm staring at, the users, any user in your environment, their email backup is now in my Outlook. If your organization has created it in digital data, I probably found it somewhere on an SMB share. So that's why it is so heavily targeted when we do these internal assessments. So SMBMap is wonderful and all, and I use it on every engagement, but there's also a lot of other tools I use. I want to just touch on those really quickly to kind of give you an idea of what they're good at and what gap SMBMap still kind of satisfies within this larger context of a suite of tools or a complement. So Metasploit is one that you use on almost on every engagement, not just for SMB. It's got a wealth of useful things that it can do. But the one thing in terms of SMB that I find myself using it for most often is the password spraying attacks. So it's a good threaded tool. It's stable. It sometimes can let you know like when an account is locked out, which is kind of nice. So that's the SMB login module. There's another one. Let's say if you have administrative access on a number of hosts in the environment, and you want to elevate to the domain administrator, you can use another module called SMB and new users domain, which gives you an idea of what users are logged into specific systems. So you can kind of cross-reference that with privileged groups and say, hey, there's a domain admin in this, and that helps you prioritize targets for attack. It also does, command execution, just like SMBMap. There's a Noom for Linux, so SMBMap might allow you to kind of identify hosts that have a null session. Noom for Linux allows you to really dump a ton of useful information. And really, it's just a wrapper for different command line tools, SMB client, RPC client, NMB lookup, and a tool called Polynoom, which is more of a packet-based password policy enumeration tool. But they, included it in Noom for Linux some time ago. And what it's good for is null session exploitation. So we kind of referenced this earlier. You can encounter a situation on a domain controller where you can dump all of the users' accounts, groups and group membership and password policy information. That gives you an idea of what the failed authentication reset counter is. So, if I have 2 failed authentication attempts and the maximum is 5, when does that counter get set to 0? Those kinds of things, and what the maximum password age is, the length. But it's a great tool for leveraging SMB to do those kinds of attacks. And then there's Crack Map Exec. And this is basically SMBMap on steroids. If you actually look at the Crack Map Exec GitHub, you'll see somewhere in there that SMBMap is listed as an inspiration. And who knows, maybe some components of SMBMap are still lingering around within Crack Map Exec. But it's a Swiss Army knife for lateral movement within internal network environments. And it does this largely through leveraging SMB. It's basically got a one-to-one matchup for every feature in SMBMap, but it's complex. It is a deep, deep feature set. So it has to have databases that are set up to store all the data. It has to have modules installed. It has to have dependencies installed. So setting it up is not nearly as easy as setting up SMBMap. And with that complexity also comes more complex syntax. So it's not quite as easy to just plop down and start using the tool. It takes some knowledge, familiarity, and because of that, I still kind of use SMBMap as my go-to for most things SMB share related. But that said, I love Crack Map Exec. It's an awesome tool. And finally, we have Responder. So you might have remembered from the SMB protocol 101 slide that SMB itself is underpinned by NetBIOS, right? So this is for name resolution. And the one thing that you can do with a broadcast protocol is poison a response. So these things, different hosts are shouting out requests for hosts that may or may not exist. That's not quite important to Responder. What is important is that we're the first host that responds to that request for a name resolution, and instead of the legitimate host, returning an IP address, our man in the middle attacker or Responder returns our IP address. And at that point, traffic is now routing through us. So that enables the attacker to then start sniffing SMB connections, and through that sniffing attack, you can find things like net NTLM version 2 hashes floating around the network. And if you're lucky enough, you get an admin one, and you could relay that to some other host, and now you have remote command execution, all because SMB at the is backwards compatible with protocol version 1.0 and thus supports NetBIOS name resolution. And finally, most operating systems have some SMB protocol or a client built into the operating system itself. So in OS X, this is in Finder. Windows, it's in Explorer, and Linux kind of depends on when you're in GNOME or KDE. But the File Explorer generally has a means through which you can then connect to some SMB share just out of the box. In OS X and Linux, it's going to be more of an SMB : / so it's formatted much like the URL for a web server. In Windows environments, it's // the address and then the share name. So syntax is a little different, but the functionality and the connectivity is identical. So we went over all those tools. What is SMBMap? Well, it's a handy SMB enumeration tool. And while all of those tools are great, the differentiator for SMBMap is that it returns the information on shared drives, including the permissions and comments. And the permissions are really what makes SMBMap useful. The syntax is also very, very approachable. So it's an easy tool to use. On the back end, if you really wanted to dive into the code, it is based on a packet. It happens to be a dependency of SMBMap. So if you want to use it, you have to install the Python library and packet, along with a few other ones. But it offers upload and download functionality, and really these are built in for features, but they're also built in because a lot of the functionality that makes SMBMap so useful is used by the functions within the tool itself. So with SMBMap, you can also query the OS information on a host. So if you wanted to say have a list of 400 SMB servers, and you needed to find the ones that were operating Windows 2003 still, either because you wanted to see if they were vulnerable to MS 0867, which really shouldn't ever happen in this day and age for a 12-year-old vulnerability, but hey, sometimes you get a little bit lucky. More often than not, endpoint protection will catch those. But SMBMap is a quick way to go about getting the operating system information for a list of hosts. It can work with a single host at a time or a file containing a list of hosts. Not everything is necessarily conducive to a file of hosts. Some upload, download functions, those are kind of specific to a specific share and a specific path within that share. So it doesn't make a ton of sense to do a mass upload, but you still can. It just doesn't make a ton of sense. And the other thing that makes SMBMap so useful is that it makes probing for sensitive files an easier task. And you can do this through matching file names against a pattern, and even do like a remote grep against the system. So you can say, hey, launch a grep job, which is really just a PowerShell job on this path within this share, and return any files that contain this string. And finally, you can do remote command execution in the form of psexec or WMI command execution. So, like, get ahead of ourselves. That's what SMBMap can do. But first things first, you want to make sure that you have some familiarity with your network environment. You want to know where the hosts that actually have SMB are, because the one thing that SMBMap isn't is multi-threaded. This is kind of a deficit in my development acumen. I'm just not a great developer. That's why it's a single-threaded application, and it's not the world's fastest, but it works. So to really get the job done quickly, SMBMap will detect if port 445 is open on a host, but the easier way is to just use Nmap. Do a SYN scan, make it a little bit fast, search for port 445, input your list of IPs so that'll be representative of whatever the subnets are in your internal network, and then finally output all of it, which just means output to XML, Nmap, and GNmap. GNmap in this case is pretty much the easiest to sort of filter out which IP addresses are going to be hosting 445. You just grep 445/open, and you got the list. The one other handy thing you can do with Nmap that is related to SMB and some of the attacks that we referenced in the other tools, specifically Responder and NTLM RelayX, is identify hosts that have SMB signing disabled. And you can do that with the SMB security mode script. So just not going to go beat a dead horse. That's the syntax for identifying hosts on your environment, in your environment rather, with Nmap. So that'll get you the list of IPs that actually host SMB services. So out of the gate, the easiest attack that you could possibly perform with SMBMap is to find null sessions, and maybe even a unicorn. We'll kind of get into what that means a little bit here. So a null session is just any system that grants you some level of access to the host without any password or any username. So null or anonymous authentication. Once in a blue moon, and I've done hundreds and hundreds of assessments, maybe even creeping towards the thousands. I found maybe 4 or 5 instances where a null session literally granted me access to admin and $, which means you can do remote command execution. And although rare, it's just really, really cool when you can have such a low effort, high payout attack. It's like kind of hitting the jackpot in the slots. So first things first, generate your list of SMB hosts with Nmap, and then using SMBMap, and this is as simple as the syntax could get for this tool. You can see here that it's just SMBMap. We input the host file and then hit enter. By default, SMBMap always uses a null username and a null password if it's not provided on the command line. So that makes quick, dirty work of trying to identify what hosts you might have the null session on. If you really just wanted to find those that had you had admin access on, you can do the --admin. It kind of reduces the verbosity. And if you really even wanted to shrink it down more, you can do a -q, which suppresses things like authentication failures and hosts that don't have port 445 open. And that will return the list if you get lucky of hosts that have a null session that you also have admin rights on. And like I said, it's not common, but it's a pretty low effort, low complexity attack. And if you do happen to find that unicorn, man, you pretty much have a direct pathway to at least probably getting domain admin through lateral movement, but it's a great place to start from 5 minutes into an engagement. So with that in mind, let's just do a really quick demo here so we're not boring you to death too much. And just see quickly here what it looks like. So you can see here, the syntax is simple. We're just going to do this host file, and let's just show you what's in the text file here. So it's just 5 hosts. Some of them have SMB enabled, some don't. Okay, so we'll run the command. Cool. So, we have of those hosts, it looks like 2 of them aren't even hosting SMB servers. One of them we didn't successfully authenticate. One of them, it allowed us to authenticate, but it granted us access to nothing. And then finally on one of them, we actually had a legitimate real null session where it granted us access to at least a list of the shares, but you can see here, we can't access any of the data on those shares. So not a ton of useful data out here. And if we did admin, it won't return anything because we don't have any admin access. And if we did -q, you'll see that it'll suppress the errors and it should just return a blank line. But that's how you can do identification of a null session on with SMBMap. All right, so moving on to the next thing that I always do on an engagement. Enumerate share permissions. So this is crucial because if you look at all of the other tools that I mentioned before, Enum for Linux, Metasploit, CrackMap exec is the exception. It will enumerate the permissions. I'm not as familiar with the syntax, it's not nearly as easy to use. So I always use SMBMap just for this very generic use case. And what it'll do is tell you if you have read, write, or no access at all on the SMB share or the SMB host that you're interacting with. And this was the primary reason that SMBMap was created, because there was no tool that actually did this. And to this point, there was no really easy way to, in mass, evaluate the contents of an SMB footprint within an internal network. So it's shining a light where a light has never been shined on before. And that's why SMBMap exists. So the syntax is really easy. You basically, we did the null session, so we know that we don't have access to a lot with no username and no password. So let's assume that somehow you've gained access to a very low privileged account, right? Admin in the example, it's obviously not low privileged, but it gives you an idea. It doesn't take More often than not, all you have to have is a domain account that's at least a member of the domain users group. And that is the bare minimum to be a domain user, to be a member of the domain users group. So that's almost no privileges at all. And you would be surprised just how much within these corporate environments you can gain access to, because all of the permissions are misconfigured. Nobody has any visibility into it because it's just so numerous. There might be 400 hosts, and of those 400, there might be 5 shares that every domain user can access. So you can see how it can quickly spiral into an insurmountable problem, and that's why SMBMap exists. So one thing that's worth noting, because of these, all being domain connected systems, and more often than not on an internal engagement, we're focusing more on the domain privileges versus the local privileges. So because of that, we'll try to get as many user accounts compromised as possible, credential pairs. So we have a spectrum of privileges versus just one, group membership. You hope it's at least a spectrum of privileges represented by the user accounts that you've compromised, but it's worth trying multiple user accounts across the same IP range to see if the threat landscape changes at all. So you might find that one user doesn't grant you admin access to anything, whereas another user, you might have 1 or 2 hosts that it grants you access to. And it's always worth trying. On most engagements, I'll try up to 5 or 6 of these hosts. If I don't hit pay dirt with the first 5, I guess I should say. If you hit admin out of the box, it's almost not even worth going about trying other accounts. So that's really only if you have a low privileged account and you're hunting for that higher privileged account. But we'll jump right back into a demo so we can show you what the output looks like when you actually use credentials. So we'll use the same host file there. And what we'll do is use my super secure passwords. Now, this account is not an administrator on most of them. You can see here. Oops, especially when you mispronounce the name. Or misspoke, rather. Okay, this should give us a little bit more. Cool. All right, so you see we have access to 1 more share. It looks like this user actually is, in fact, an admin on at least 1 box within the environment. And this is what it looks like to enumerate the shared permissions. If we want, we can apply -q, which means quiet the verbosity of the output. And really, it just shows you the relevant data. So you can see that it trimmed the output to only include the hosts that we have at minimum read access to, and also read write. You can see that we no longer have anything within all session reported. And if we change this to administrator, which should give us a few more listings, we now have access to additional hosts within the environment. So that's what it looks like to enumerate shares, and that's why it's so useful on an engagement. And if you want, you could apply a -r, which just means list the root directory of anything that we have access to. And you can see here that it, then for each of the shares that are representative that we have at least read access to, it will list out the contents of that share. Oops. We'll go to, sorry, too many windows open. Okay, back to the slide deck. Okay, so one of the more cool use cases that you can use with SMBMap is to compromise a web server. So it's a surprisingly common how often you might find the web roots of an application server exposed through an SMB shared drive. This is bad for a couple of reasons. It depends on the permissions that you have assigned for this particular web application resource. But at worst, you have read access to the web root of a web application. So you now have access to the configuration files that support that web application and the source code of the application. Once you can kind of look at the source code, you can identify things like SQL injection. You can identify cross-site scripting. You might find hard-coded credentials, either in the source code itself. Oftentimes, particularly on .NET applications, you'll look at a web.config and see database credentials. So you've expanded the attack surface again. You can now bring a database server into the fold, which is another good vessel for remote command execution, depending on the privileges of the database credentials you've just compromised. So having any web application source code exposed is bad enough. Sometimes you find that you have this awesome confluence of misconfigurations where basic domain users have rewrite access to this web application that's hosted internally. And those confluence of conditions facilitate remote command execution. So first thing you want to do when you're trying to identify these SMB shares that may or may not be web servers is identify which ones are web servers. So there's two approaches you can use. There's the dir only and greppable format method. And when you do this, if you recall from the directory listing, right, it displayed files and directories within this output. If you do dir only, I'll just show you real quick. All of the files are suppressed, and all we get is the directory listing, right? So if we take that a step further, we have the greppable format. So that just takes everything that we're doing and makes it kind of more grep friendly. So then I can say, okay, well, just, show me all of the instances of htdocs or www or www root or inetpub or something like that within that output. And we'll assume that that might be a host that we can then target in other attacks. So that's one method. I generally don't use that one. I use the automatic file download method, but each their own. If you happen to go with choice B, which is -A, and the -A argument instructs SMBMap to automatically download any file that matches the regular expression defined in the following pattern. And with this kind of a flexibility, a regular expression can match on a lot of different things. So we can kind of use the predictable nature of a web application server across a lot of different environments. If it's a .NET, we might have a web config. If it's a Java-based, JBoss or CentOS, it might be that it has a web.xml. If it's Apache, it might have a server.conf. It might have an httpd.conf. There's all kinds of possibilities. So we want to be able to have one pattern that sort of matches all of these possible scenarios. So you can see the pattern that we've elected here. It goes for config, server, index, web, httpd, and it's going to look for any of those strings followed by the extension config, XML, HTML, PHP, and conf. And I'm pretty confident that this, in most cases, will at least get a few hits. It might not be indicative that it's the web root of, of an application server. That totally possible that it could be like a help file or something like that. That's just floating out there, but it's a good pattern nonetheless. And this is the way that I like to use SMBMap to identify those web server shares. So let's say you go through your due diligence, you use method 1 or 2, and you do find that one diamond in the rough. You found your web server and you've enumerated the permissions on it using SMBMap, and you said, I think I have read-write access to the web root of this application server. So from there, you can actually use SMBMap to upload your favorite web shell, whether it's ASPX, PHP, JSP, you name it, to the vulnerable misconfigured share, and then access that web shell in a browser and remotely execute commands. And this is a really, really great stepping stone to privilege escalation and really entrenching yourself in the environment. So let's go over to a demo. All right, so the goal is to identify systems that have a web root. Now, see, somewhere up here I've executed this command. Let's just clear this first so we can get rid of some of the clutter. And find this. And then once we get it on screen, I'll kind of explain the syntax. Okay, here we go. So, same command syntax to a point, so username, password, all pretty standard, get loaded in from the file. The -R is different, so that's a new one. That means we want to do a recursive scan of all of the directories that we have at least read access to. And the depth just kind of controls how deep it's going. So this avoids rabbit holes. You don't want to go down some directory tree that, is 20 levels deep and contains hundreds of files. And, that's basically, when you're talking about that, it's more or less like your C $, your admin $, where it's just tons and tons and tons and tons of files. And this helps increase the performance, which it has a significant impact on a single-threaded application. The exclude parameter here just says that we want to avoid some shares that we know have 0% chance of ever containing the web root of a web application. So admin IPC And for performance reasons and a webinar, I've also included $C$ and C because I know that's not the location. We are going to quiet the output because I don't want to see the directory listing as we're doing this kind of a search through all of the directory trees and traversing them. And finally, we have our -A, which is the automatic download flag, and it will auto-download any file name that matches this pattern. So let's run it. Okay, so you can see it's starting these searches. Didn't find anything on that one. Started a search on print. I guess we could have avoided that too. htdocs, and you can see here that htdocs actually resulted in a match. So I think this host right here has a strong chance of being the web root of a web application. And we can type in ls, and you can see here that the files are downloaded and named in such a way that you can tell precisely where this came from. So just looking at the file name, I can tell you that it originated from the host ending in .20. The share was htdocs, and it was in the root of the htdocs directory. So it was config.php. Great. Well, one thing we can do out of the gate, if we wanted to, would be look at the contents of that file. And you can see here in this example that it just contains credentials. Now, this is a surprisingly common attack. This would be bad enough on its own, right? We're looking at the source code of a web application. But if you recall, what we'll do is replace this with the host in question, 8620. Oops. Yeah, it'd help if we use the right accounts, huh? Okay, so using the administrator account, we do have read-write access to the htdocs. So that means that we have an opportunity here to upload files to this web server, which is just awesome. So what we'll do is list out htdocs just to see what's in that directory. All right, so we can see we have a config.php and index.html. What we want to do is put our own web shell there, so something that we know we can execute. So we'll get rid of these, and we're going to do an upload. And the source for me is going to be in my scripts directory, webshell.php, and we want to upload it to the htdocs share. And we're going to call it nopsec.php. And we're going to hit enter. And there you go. It uploaded our very, very small web shell. And what we can do from here is go to our browser and access that share. Cool. So it's working. You can see that we have the everything functional, and let's execute a command to just verify and validate. So on Linux environments like this, it's always fun to do etc password out of the gate. Cool. All right. So using SMBMap, you could see how we identified an SMB share hosting a web application, uploaded the file, and actually achieved remote command execution because of the misconfigurations on an SMB share. So these are the kinds of things that SMB makes relatively easy in mass. So you can do it across multiple hosts, and it's a pretty nice feature. The same capacity that we used to find the config files and the web server related files can be applied to anything, generically. So like we said, you can do file listings in a few different ways. So when you want to find sensitive files with SMBMap, you're basically talking about matching file names against a regular expression. And it just checks the file name. It doesn't check against the contents. And you could do this in a few different ways. You can use -R, which we kind of illustrated before, is used to just list the root of every share. So it gives you a loose idea of what's in there, but it doesn't tell the full story because it hasn't traversed any of the directory paths that might be below that primary share root. Or you can use a recursive listing, which is going to go exhaustively through each and every level of that directory tree until it's taken a look at the contents of every directory. It's kind of a black hole when you do that. I wouldn't recommend it. Always use the depth parameter, which controls how deep that SMBMap is going to traverse. I find that a good balance is maybe like 2 or 3. That way you can get decent coverage, But once you kind of go beyond that, you start getting into some, crazy paths. More often than not, aren't going to contain anything useful. It's well suited for ripping through hundreds of SMB share drives for sensitive data. And you would not believe how frequently that this just has troves upon troves of information. And it's, you can search for anything: password, web configs, source code for applications, payroll. One of the things I like to do is use it with quiet exclusions, because I don't care about an admin and $. I'm more interested in what HR data or email backups and things like that that are available out there. And like I said, the traversal depth. So these are all very handy things that can limit the output and speed up the results. And we'll show a quick use case here on how I use this to, say, scrape a bunch of hosts for instances of a string, of any file with a string password. And just to keep it short, I don't know, this should help us get, any Etsy passwords as well as the full string password. So that's why we're just using a fragment there. All right, let's see what this thing outputs. And we'll do recursive because it's implying anything. Do a depth to 2, go back to the A, and we're going to flick on Q because it's a recursive directory listing. Okay, so there it goes. It's kind of traversing. You know what? We're going to cancel it because it's going to take a while for those. We're going to use exclude to exclude. All of these shares, I think print $. Yeah, that looks complete. Cool. It still didn't find anything. Maybe it was depth 3. Haha. Pays to prepare for these things. Okay, so you can see that we actually got a hit that time with a user share in the administrator's folder. So and it was on host.43. So we'll do cat 3, and you can see here that we have a few passwords that were lingering around. And that's how you can use SMBMap to kind of quickly carve through lots of SMB shares for sensitive files. It's pretty flexible in that capacity. Oops. Okay, so that by no means encompasses all of the functionality, but that's the most common functionality that I use in an offensive capacity on an engagement. So that's what helps me identify which systems might be at risk because they have misconfigurations that expose really sensitive data. Now, I'm sure it's impossible for somebody that's coming in from a third-party perspective to point a finger on something on a SMB share drive and say, hey, that's really important. That's really critical, because to me, it's a spreadsheet with some numbers and figures. It might be more meaningful to somebody that's, say, a competitor. So it's really difficult for a third party coming in to easily determine the value of a piece of data. It's much easier for me to understand a technical piece of information, such as a password. Obviously, if I see a social security number, I know that's pretty bad. If I'm seeing account numbers, I know that's a information disclosure you would not want to have. So it also has the other features, and we kind of touched on these in the what is SMBMap slide. But it can be used to do the OS information, execute system commands. One of the least tested features that I've recently introduced is a file content search, and this is really just like a remote recursive rep. So the idea being that you can define a pattern, and what SMBMap does is start a sub-process on the target host and runs a PowerShell script that'll actually do this rep recursively on a whatever directory you define. I think the default is C:users, and returns any file that contains an instance of that string. So this is unlike the -A, where the -A just matches a file name. This matches the contents of the file, skips the file name entirely. And finally, you can do like a drive listing to show you what local and network drives are mapped on a host. But just to give you an idea, we'll do a demo of a few of these commands so everybody is familiar with, has a more complete picture of what the functionality is. So, okay, so we said the dash F. So, well, we'll go easy. Dash V, we'll just find out what the version of all these hosts is. So we can see one interesting thing, for whatever reason, SMB on Debian seems to always report as Windows 6.1 build 0. It's an interesting tendency. I've seen it across a few different Ubuntu and Debian servers, but really easy to get those. We can also do a -L, which will return the network drive. So a few of these things have caveats. -L, to list the drives, that actually requires admin rights on the target host, because on the back end, what you can't see is that it's using WMI command execution to run a few CMD commands that eventually lists the output that you see here. So we can see that there are CD, Y, and Z drives mapped, no mapped network drives, and on this host, .43, we have a few different drives that are mapped and shared. If we use the -F, which means do a file content search, we can search for instances of the string password, for instance. Oops, didn't run as root. So one thing with -F, when you do a file content search, one of the features of SMBMap is that, like we said, it will start a sub-process on the target host. And the one thing we don't want to have happen, when you launch the sub-process and you're doing this recursive grep, it can have a CPU spike. And depending on the size of the drive and the path that you've defined to search, it could take a while. So the idea is that we don't want this process to run forever, and just consume 80% of the resources on a machine while it's executing. So it hosts a PowerShell script that will allow it to determine what has a lock, what process is locking basically this output file here. And if it exceeds a timeout threshold of like 300 seconds by default, it will kill the process that is locking that job. But you can see when it finished that we have a list of all of the files on that system that had an instance of the string password. So you can see a lot of these are in the, these are just support files for runtime extensions for something. So they're probably not going to be clear text passwords that we can use, but we do see these two files here, SQL uses passwords and test.txt. So those might bear further reconnaissance and evaluation. And like I said, this requires, much like -L, this requires administrative rights on a system because you are in fact doing remote command execution of WMI. This is just kind of packaging everything in a nice little digestible format. And I think pretty much should cover it. Did I miss anything? Oh yes, remote command execution. Can give you a quick idea of that. So let's say if we just wanted to get the IP address of a bunch of hosts, because we wanted to find out which ones were multi-homed. So, what host on your network is connected to the environment that I'm connected on, but also an entirely different subnet. And you can see here that we've got admin right on 2 boxes, and we have an IP config for both of those. So you can, do that with any command that you want. Echo command. So gives you an idea of what you can do with those various commands and files as input. Oops. Okay. So that more or less concludes everything. I hope everybody found it informative. I hope this enlightens why SMB is such a critical component to a thorough evaluation of risk within an environment. So, you got to step away from just pure vulnerabilities and sort of focus on why all of the controls exist in environments, and that's to protect the data. And when you have anybody on your network being able to access all of this sensitive data, you're missing. You have a huge blind spot in terms of risk. And that's where SMBMap comes to the rescue to help you hopefully identify the location of some of that. Thanks everybody for attending.
All right, thanks so much, Shawn. Let's give a couple minutes if there is any questions from the attendees. All right, I'll wrap it up. Great. Thanks, everybody. We appreciate you being here. Thanks again for joining us today, and we will see you next time.